All right, we'll go ahead and get into our next section of notes here. So this is going to be 10.2, and today we're just kind of transitioning and moving to the next step here. We talked about area in 10.1, and now we're talking about volume in 10.2. Okay, date that we're doing this is going to be on the 20th, and our objective for today is we really just want to be able to find the volume of any 3D shape. I mentioned this a little bit in the last notes, but again, usually we'd have some time to kind of go through some of these shapes individually, and spend some time focusing specifically just on volume of a prism, for example, and then the next day volume of a cone or something like that. But with the way our schedule is going and the pace that we have to move, we're kind of just combining them all into one unit here. So there might be some problems that you see on the homework that we're not going to have time to do any examples of on these notes. Again, it's just going to come down to using the formulas that we write out today. Okay, so first off, if we're talking about volume, what does that mean? Okay, the volume of a 3D shape is just the amount of space inside a 3D figure. Okay, amount of space or volume inside a 3D figure. So one example, a simple example that you'll see like on word problems and stuff in past classes would be like find the volume of this pool, or how much water total is in this pool here. Okay, it's a 3D area, 3D space, and you want to figure out how much or you want to figure out the amount of space inside it. Okay, so for these here we have some formulas that we can use. So for instance, the first one, volume of a prism. Okay, volume of a prism is just going to be this. It's just going to be V equals, and it's actually going to be still B times H, but except in this time I'm going to use capital B. Okay, so volume equals the capital B times the height. And I'm going to write this to the side here. I'll say capital B equals the area of the base. Okay, the area of the base here. Okay, so the volume equals that. Okay, or another way to think about it, circle this here. Okay, since in general a prism usually has a rectangular base, or a base that's just a parallelogram, another way to think about this is the area of the base is just going to be length times width. So I could say length times width times height. Okay, that's another thing that you can use, or the way that you'll see how area can be used here. Okay, but in general, you're going to see the same pattern with a lot of these 3D shapes, is it's just basically finding the area of one of the 2D shapes and then multiplying it by the height. Okay, and I'll explain that more when we go through some examples here. Okay, next one here, volume of a cylinder. Okay, the volume of a cylinder is going to be the exact same thing. So for example, a cylinder would be like a soda can or something like that, okay, or a water bottle. So volume of that is also going to be the area of the base times the height. So again, capital B, not small b, but capital B, meaning the area of the base. Okay, or since it's a cylinder and since the base is going to be a circle, we could just take the formula for the area of a circle. So it could be pi r squared and then times the height here. Okay, this would be the volume of a cylinder. And in general, I would usually recommend using this one here. Find, if you need the exact measurements, you can use the radius and use the height and just plug it into that equation. But this is the basic idea when we're going into 3D shapes. Okay, if you want to find the volume, you're finding the area of the base, whatever that is, and then just multiplying it by how high I would stack that base on top of itself. Okay, so for example here, example 1, this is a little bit easier to understand when we can look at a picture of this. Let's say we have this prism here. Okay, so we have this prism and we want to find the volume of it. Well, if I can try to visualize this a little bit, notice how I would create this prism is I would really just take this right triangle that I have here. So this one right here, okay? And let's say we just lay that flat on the ground. Okay, if we laid that flat on the ground, that would be the base. And then to create the rest of the prism, I would just need to keep stacking these triangles on top of each other again and again and again until I get to the height. In this case, that would be 11 centimeters. Okay, so this is where our formulas are going to come into play. So for example here, I could write the formula out if I need to from the start. The area of the base times the height. And the base is always going to be the part that you could stack on top of itself. So notice in this case, like I said, to get from one side to the next, we could just take one triangle and then just keep stacking it over and over and over again until we get the prism. So the area of the base here, or capital B, since this is a triangle, we talked about area of a triangle last time. That's just base times height divided by 2. So in this case, that's going to be 10 times 12 divided by 2 here. Okay, and in any case, whatever you do to solve that here, that's going to be 60. And then I'm just going to get in a good habit of marking this with my label here. It's going to be centimeters, and since it's area, it's going to be centimeters squared. Okay, so this would be the base. This would be the area of the base, 60 centimeters squared. Okay, this triangle right here. Okay, and then if I start stacking that, I'm just going to stack it on top of itself until it gets up to my height, which is 11 centimeters here. So volume is going to equal the area of the base, 60, times the height, which is 11. Okay, and then I could just type this into my calculator if I didn't know. This is good mental math for you, but this is going to be 660. Okay, so 660, and then when we're in volume, we're going to go one step further with the unit. This is going to be centimeters cubed. So anytime you're talking about area, you're saying squared, and then anytime you're talking about volume, you want cubed, or in other words, to the third power. Okay, so this is how we find the volume of a shape. Okay, find the area of the base, multiply it by the height. Okay. Now, we have other things that we can do as well that are unique examples of this. Specifically, we have some that are pyramids and some that are cones. Okay, so next one here, volume of a pyramid. Okay, if I can think about what a pyramid looks like, okay, I'll try to draw this. It's going to be a rough sketch. Okay. If I can think of what a pyramid looks like there, it's actually just the same thing as a prism, except when I do the length times the width times the height, I actually have 3 times as much as I need. Okay, it's actually too much. So the volume of a pyramid is going to be 1/3 the area of the base times the height. Okay, the volume of a pyramid is always going to be 1/3 the area of the base times the height. Or, for instance, if your base, like in this one, is a rectangle, then I could say the volume equals 1/3 length times width times height. Okay, so that's the only difference that you're going to add in when you talk about volume of a pyramid. It's the same kind of idea, except it's only 1/3 of it. Okay, because it's not the entire prism. All right, and then same idea here as well. Similar kind of concept with a cone. Okay, a cone is just a pyramid that has a circular base. So for instance here, and here, if I can think about what that looks like, same kind of idea. We're going to say volume equals 1/3 the area of the base times the height. So same exact equation. Okay, it's just 1/3 of what I would normally find. And then like I said, the reason, or in this case, our cone has a circular base, so the area of the base is always just going to be the area of a circle. So I could say volume equals 1/3 pi r squared times the height. Okay, so very similar equation to what we just saw with a cylinder, except 1/3 of it. Okay, so like I said, it might be confusing as to how we're coming up with these equations. That's okay. Really, all this unit comes down to, as I've mentioned before, is just making sure you know how to use these equations and making sure you know what value should I plug in where here. Okay, so again, let's practice that a little bit and see what this looks like. Okay, so for example 2, let's say I have this cone here and I want to find the volume of it. Okay, and we notice here we're not actually given one of the values yet. We're not given the radius. We're going to have to find that. Okay, what we are given is we're given the height of the cone. We see the height of the cone is 11 inches, so that's good. That's going to be helpful. And then we're also told that this angle measure here is 58. Okay, well, if I want to go to the volume of a cone, I can just look back at this equation that we just wrote down. That volume is going to be 1/3 pi r squared times the height. Okay, we have 1/3 and pi are not going to change. We have the height, so the only other thing we need to find is r. And so if I'm looking at this and I'm trying to figure out how could I figure out what the radius of that circle is, how can I figure out what that length is? Well, notice here I actually have a triangle inside all of this. Okay, and if I really need to, I could draw this to the side where I have a right angle right here. I have r, I have a height of 11, and then an angle measure of 58. Okay, and if I gave you this problem, since it's a right triangle, remember we can use trigonometry and we can use all those things that we talked about in the last unit. Okay, so for instance, in this case, 58 would be our focal point, 11 is opposite of the angle, r is adjacent to the angle. So to set up an equation to solve for r, we can think back to our trig functions, opposite and adjacent, which one would that be? that would be tangent, if I'm thinking of SOHCAHTOA. So tangent of 58 equals opposite over adjacent here. And then as well, we talked about this little trick that we have where if our variable is on the bottom, we can actually just switch the value of these two things. So I can say this is the same thing as saying r equals 11 over tangent of 58, okay? And then from here, all I need to do is just type this into my calculator and let that do the rest of the work. Okay, if you need to, if your calculator does not hold the decimal in place, or you're not able to enter it in one step, you could just find the tangent of 58 first and then do 11 divided by that decimal. Okay, but in any case, when you type this in your calculator, you should get r is roughly around 6.87. Okay, you could round this off to the 100th or the 10th place. It doesn't really matter either way. You'll get an answer that's close enough to what you want here. Okay, and really if you wanted to, you could keep, if your calculator allows you to, you want to keep that decimal in your calculator. Okay, that'll give you the most exact answer that you can have. Okay, but in any case, here's our radius now. It's about 6.8. And now that I have that, I can plug that into my equation that I wrote down from the very start. So I said the volume is going to equal 1/3 times pi and then times r squared, so about 6.87 squared times the height, which again we have as well, that's 11 here. Okay, and so I would just take this a piece at a time. I have this decimal in my calculator right now, 6.87, 35, whatever, it keeps going. So I'm going to square that, get a number, and then I'm going to multiply by 11. And then I'm going to multiply by pi. And when I get to this step, I'm somewhere around 1600, of about 1,632. Okay, and the last step, I need to multiply by 1/3. So I've gotten this part, I've gotten this part, I've gotten pi. And then if I want to do the 1/3 part, another way to think about it is just dividing this all by 3. So I'm going to take whatever that answer was and divide it by 3. And so if you type all this into your calculator correctly and kept all the decimals in there, your answer should come out to be about 544 point, and then I'm just going to round off to the 10th place, and I'm going to say 2. So 544.2. Okay, and then last step, always good, like we've been doing in this unit, I want to include the units. So this is going to be inches, and then since it's volume, it's going to be inches cubed, or in other words, inches to the 3rd power. And that's going to be my final answer. Okay, so that's a lot of what this chapter is. It's just making sure I understand what the equation is, and those you don't need to memorize. You can just take those from the notes, what we write down, and then once you have that, you just need to gather all the pieces. So do I have the height? Do I have the radius? And then plug that in. Okay? All right, last step here, last type of shape that we need to talk about is the volume of a sphere. Okay, so we've talked about cones, we talked about pyramids, talked about prisms and cylinders, and now the last one we need to talk about is the volume of a sphere. And again, this one is just derived from mathematicians working this out and using the information that they have here. Okay, so the volume of a sphere is it's a little bit different than the others. It is 4/3 pi r cubed. Okay, so make sure you see the big difference between this one and a lot of others. Anytime I took r to an exponent, I usually take it to the 2nd power, or it's usually r squared. But with volume of a sphere, it is r cubed. Okay, and specifically it's 4/3 times pi r cubed. So make sure you're paying attention to make sure you're paying attention to these formulas here, and make sure that you understand where you need to plug these pieces into. Okay, and we know what a sphere is. A sphere is just like a ball, just a round surface where all the points on the outside are equidistant to the center. Okay, it's just a 3D shape. Okay, so last one here. Let's say we were given part of a sphere. Let's say I want to find the volume of this hemisphere. Okay, I have that the diameter is 14 here, and I want to use that to find the volume. So first off, make sure we know what equation we're using here. This is part of a sphere, so at least I'm going to use that equation, 4/3 pi r cubed. Okay, and let's just work on finding the volume of the whole sphere first. Okay, well, if I want to list out my pieces, if I need my radius here, notice the radius is not 14. Okay, the diameter is 14, which means the radius is going to be half of that. So the radius here is 7, okay, or 7 inches. Okay, now I have that. Now I can plug this into my equation. So let's say volume of, let's say the whole sphere at first, equals, and then we're just using that equation, 4/3 pi r cubed. So 4/3 times pi times 7 cubed. So this is the big piece that you need to know how to do. From here, it's just your calculator can do the rest of the work. So I'm going to start off, I want to do exponents first, so I want to cube the 7 first. So I'm going to type 7 cubed into my calculator, or in other words, 7 to the third power. Whoops. So 7 to the third power equals 343. And then I'm going to multiply that by pi now. So multiply that by pi. Should get something around 1077. And then this last piece here, if I want to multiply by 4/3, if I wanted to, I could just do it in multiple steps. This is the same thing as multiplying by 4 and then dividing by 3. So let's take our 1000 number-ish that we have. Let's multiply that by 4 and then divide that by 3. And so roughly the volume of this sphere is about 1436.8 if I round it off. Okay, if I round it off, that's what I'm going to get, about 1436.8. And then remember, I want units here, so this is going to be inches cubed. Okay, so this is the volume of the entire sphere, but remember, it wanted us to find the volume of the hemisphere, or in other words, I just want to take that and cut it in half. So the volume of the hemisphere, and I could have done this in my equation as well, okay, either way works. Okay, but the volume of the hemisphere is just going to be half of that. So I would say just find your answer and then cut it in half. So about 1436.8 divided by 2. And what I'm going to do is I'm just going to keep this decimal in my calculator. So right now I have the whole decimal. It spits out 1436.7550 something. Okay, I'm going to keep that in my calculator and I'm just going to hit divided by, and then I'm just going to hit 2. Okay, and this is something when I say keep the decimal in your calculator, if you guys need help with that, that's just something I'm going to have to help you out with individually. It's not something I can really explain in a video if you're not understanding it. Okay, so I hit divided by 2. I'm cutting the sphere in half, and so that comes out to be about 718.4. Okay, when I cut that in half. And then again, always a good habit to include our units. So this is going to be inches, and it's going to be cubed since we're still finding volume. Okay. So this is what we need to be able to do. We just need to be able to look at the formula that we're given and then be able to come up with all the pieces and plug that into our equations here, okay? And it just takes a little bit of practice. So homework for this is going to be 10.2, finding the volume of all different shapes. And like I said, you're going to see some problems on the homework that we were not able to go over in the notes because there's just so much information, but just use the formulas that I've given you for any of the examples that we didn't do, okay? All right, and then as always, if you guys have any questions, feel free to let me know, all right? Thanks, guys.